Okay, let's continue. We'll get 6 plus 14 divided by 5, that's equal to 20 by 5, that's equal to 4 ohm. Therefore, the effective resistance in this case is 4 ohm, 4 ohm, and there is a 6 volt battery connected. Therefore, current I is equal to V by R, that is equal to 6 by 4, that is equal to 3 by 2. Okay, 3 by 2 ampere, that is the total current is 3 by 2 ampere. The total current is 3 by 2 ampere. Since no current passed through the capacitor, the current through the 2 ohm resistor, for that we have to say this resistance is 6 by 5 ampere, and the current through 6 by 5 ampere is what? 3 by 2, 6 by 5 ohm is 3 by 2 ampere. Therefore, we could say the voltage across the resistor, it will be V is equal to IR, that is 3 by 2 into 6 by 5. That means it is V is equal to 9 by 5. Okay, 9 by 5 volt. And since V is 9 by 5 volt, the voltage across 2 ohm will be also 9 by 5 volt. Okay, so we know R is 2 ohm and V is 9 by 5 volt. Therefore, I is equal to V by R, that is 9 by 5 divided by 2, that is 9 by 2 into 5, 9 by 10, that is equal to 0.9 ampere. Okay, therefore the correct option is 0.9 ampere. Next question. When a key is pressed at time t is equal to 0, which one of the following statement about current in the resistor of AB in the given circuit is true? That is, if we are pressing the key in this situation, which statement is true? Let's read all the statements. I is equal to 2 milliampere at t, at all t. I oscillates between 1 milliampere and 2 milliampere. I equal to 1 milliampere at all t. Option D, at t is equal to 0, 2 milliampere, and with time it goes to 1 milliampere. For that, let's understand at t is equal to 0 situation, at the initial time situation, the capacitor will behave like a open circuit. Or no, it's not open circuit, capacitor will behave like a short circuit. It is behaving like a short circuit means there is no reason for current to go through this wire, it could directly go through this wire. Therefore, this resistance is not part of that circuit. Therefore, at t is equal to 0 time, this 2 volt battery, we could imagine the circuit like this. This is our 1000 ohm resistor, and the capacitor will get short circuit means this is not the part of that circuit. We could consider this. Okay, therefore in this case we could say current I is equal to V by R, that is 2 divided by 1000, that much 2 divided by 1000 means it is 2 into 10 raised to minus 3, that is 2 milliampere. Okay, therefore at initial time the current is 2 milliampere, that is this situation, and after some time it is attaining a steady state. At steady state the capacitor will behave like a short circuit. At steady state the capacitor will behave like a short circuit. That means at steady state the circuit can be reimagined into a circuit like this. This is our 1000 ohm resistor, and this is another 1000 ohm resistor. Since this is an open circuit, means this is not part of the circuit, therefore the current should flow through this 1000 ohm resistor. That's the reason. Then the total resistance in this case, it should be 2000 ohm. Therefore, current should be V by R, where 2 volt is the battery. Therefore, V is 2 divided by 2000. That is what? 1 into 10 raised to minus 3. That is 1 milliampere. Therefore, at steady state, the current will become 1 milliampere. Therefore, option D is the correct answer. Okay, now let's look at this question. The effective resistance between the point P and Q in the electrical circuit given in the figures. Therefore, we are having an electrical circuit over here, and we know Weisstone's principle. By Weisstone's principle, if the resistors are in the ratio P by Q equal to R by S, the current passing through the galvanometer is 0. Likewise, if you are looking at this circuit, over here we are having 2R, we are having 2R over here, R over here, R over here. Therefore, it's like P by Q equal to R by S. Therefore, we could neglect this resistor. It's like P by Q equal to R by S. Therefore, we could neglect this resistor. And look at this part of the circuit, R, 2R, 2R. This is also like P by Q equal to R by S. Therefore, we could neglect this resistor because no current will pass through this 2R resistor and this 2R resistor. Therefore, we could redesign our circuit diagram like this. That is, the circuit diagram can be redesigned. 2R, 2R, small r, 2 capital R, and 2 capital R. Okay, therefore we are designing the circuit diagram like this. Then from this 2R and 2R is series, therefore it is 4 capital R and R is series, therefore 2 small r. This is 4 times capital R. 4R and 4R is parallel, therefore the effective resistance of these two parallel combination, it will be what? 4R by 2, that is 2R, then that is parallel to this 2 small r, therefore this is the next combination. And if we are using R1 R2 divided by R1 plus R2, Rp is equal to 2R into 2 small r divided by 2R plus 2 small r. That means it is 4 small r capital R divided by 2 can be taken out, R plus small r. Then 4 and 2, 2. Therefore, this is your answer, and it is